In this video, we'll use a tool called Porter to install a cloud-native application bundle that provisions a database in DigitalOcean and deploys an application to Kubernetes. Porter allows you to install bundles from a local source or from a Docker repository. In this case, we're using a repository. You can see that it allows us to do things like have version bundles. This means that as we're iterating on a bundle, we can change the version and have previous versions still work. Next, we'll also provide a credential. The credential has things like our DigitalOcean access key that we'll need to provision the database and configure Terraform, as well as a kubeconfig file for deploying our application. Next, you can see that we set a couple of parameters. Porter allows you to set multiple parameters. In this case, the most important one that we want to see is database name. We'll see that in action as we hit enter. When we start to install the bundle, the first command that we see run is s3cmd create bucket. That's going to create a DigitalOcean space that we can use to store our Terraform configuration. Next, we use Terraform's init command to configure the back end. Finally, Terraform starts to run by using the Terraform apply. Notice that the database name springmusicdb has been passed down to Terraform from our CLI. This will take a little bit of time to run, so let's look at one that we've previously installed. To do that, we'll use the porter instances list command. And we can see that about 20 minutes ago, we have one called Spring Music. We can use the porter instances show command to see information about that. And here we can see status of the bundle, but we can also see the outputs. Using this, we can actually connect to the application. This is the IP address of the load balancer. So to do that, let's just open a web browser. We can see that our application has loaded. How did this all happen, though? In this directory, you can see there's a number of files. We have something that looks like a Docker file template. We have a charts directory, a Terraform directory, a bash script, and a porter.yaml file. The charts directory contains a Helm chart. The Terraform directory contains some Terraform configurations. So when we install this bundle, we're actually taking the Helm chart, the Terraform configurations, and the bash script and putting them together. And we do that through the porter.yaml. The porter.yaml first starts out with a little bit of metadata. We define things like the invocation image we're going to use and the tag for the bundle. Then we define what functionality the bundle should have. Those are defined with something called a mixin. A mixin adapts CNAB and Porter to an underlying tool. In this case, because we're using the wait.sh script, we need to have this exec mixin. That'll allow us to run bash scripts. We also have a Helm chart, so we're going to use the Helm mixin. And we obviously have some Terraform configs, so we'll use the Terraform mixin. Once we have those things defined, we can come down and define what our installation step should look like. We ran porter install, and that corresponds to this. Next, you see we have an exec call that does s3cmd create bucket. What really happens here is that we're going to use the exec mixin and call the s3cmd tool and pass these arguments. Once that's finished, we'll use Terraform. Terraform first will configure the back end, and we saw that with the Terraform init command, and then we'll pass some variables. Notice here that we're passing the database name. Finally, we collect some outputs from this Terraform step, notably the database host, the database port, the database user, and the database password. We can then use those with Helm to set these parameters. This allows us to run one tool, Terraform, and pass those values into another tool like Helm. Finally, we have two exec mixin statements. Notice here that we're going to run kubectl to get the IP address and then store that into an output called service IP. This matches exactly what we had during when we ran the last command. So you can use the porter.yaml to define that we want to use all those tools together. How do we actually build the bundle? We do that by running the porter build command. Porter build will first copy the mixins over. We said that we explicitly needed the exec mixin, the Helm mixin, and the Terraform mixin. That will copy over just the capabilities that are needed and add them to our Docker file. We then generate a Docker file that represents our invocation image and build that invocation image. The invocation image will have all of the binaries and charts and everything necessary to make that bundle happen. Once the invocation image has been built, we then generate the bundle itself. This will be the CNAB bundle. Inside of that, we'll have reference to the invocation image, but we'll also have the parameter definitions that we used. So here you can see database name. We also have our service IP output definition, and then the credentials that are necessary as well. So we've built the bundle, but how do we make it available to do the porter install with the tag reference? To do that, we would run a command called porter publish. But instead of actually running this command, we can put this into a GitHub action and utilize continuous integration for our publishing of bundles. As an example, here's a really simple GitHub action that defines a porter publish. So when a push happens in GitHub, we will do a porter publish. To do that, let's edit the porter.yaml and just change the version. And we'll change this to then we can simply commit this and push it. Now that we've pushed this to GitHub, we can simply open the GitHub UI and see the action in progress. We can see that it already completed, and we click Details. If we view the logs, we'll see that we generated the new bundle, and we did indeed push the bundle to Docker Hub. In addition to using the command line tool Porter in distributing bundles, we can actually take the bundle and wrap it in an Electron installer itself. This looks like a little something like this. The Electron installer contains both the bundle and a tool called Duffel. It'll look for the tool Duffel locally, but if it doesn't find it, it's included in the bundle itself. When we double click this, we can see that we have the same parameters that we used on the command line, such as database name and space name, along with the credentials. We can populate all of these things and then simply click install, and the tool will run behind the scenes for us, giving us a nice integrated experience that doesn't rely on the user having actually anything installed in their system.